Some dump trucks were supposed to be engineering legends, billion-dollar machines built to dominate mines, conquer construction sites, and rewrite the rules of heavy hauling. Instead, they became the most expensive failures in trucking history. Engines that destroyed themselves, tires that cost more than your house, legal battles that shook entire companies to their foundations. These are the dump trucks that drivers hated, operators cursed, and manufacturers prayed you'd forget. You won't. Number 10. The Navistar International Workstar with MaxxForce engine. Let's kick this off with a scandal that had lawyers working overtime and trucking companies absolutely fuming across North America. The International Workstar was Navistar's heavy-duty, severe-duty platform, marketed aggressively for construction applications, including dump truck work. On paper, it sounded like a workhorse. Navistar gave it their MaxxForce engine lineup, specifically the MaxxForce 11 and 13-liter variants. They promised fleet operators that this advanced EGR exhaust gas recirculation technology would meet the EPA's 2010 emission standards while delivering rock-solid reliability. Spoiler alert, none of that was true. Engineers inside Navistar were reportedly telling management that the physics of their EGR strategy simply were not sound. When chief engineers raised serious concerns, the company allegedly threatened to fire employees who even discussed alternative emission solutions. They shut down all internal work on SCR, selective catalytic reduction, which every other major manufacturer was already using successfully. Meanwhile, Navistar was burning through stockpiled emissions credits between 2010 and 2012, using them to mask the fact that their MaxxForce EGR engines never actually met EPA 2010 standards. Customers had no idea. They were buying dump trucks, mixers, heavy haulers, trusting that the machines would perform. The results were catastrophic for operators. Fleets reported sudden engine derates, a sudden loss of power while hauling full loads on highways. EGR coolers cracked, turbochargers failed, DPF systems clogged. One trucking company in Washington state reported losing more than 150 days of revenue from a fleet of just 14 trucks due to continuous breakdowns. Multiple class action lawsuits were filed across California, Illinois, Texas, Tennessee, and Washington. A Tennessee jury alone hit Navistar with a $30.8 million judgment, $10.8 million in actual damages and $20 million in punitive damages, finding that the company had committed fraud. Navistar eventually settled a broader class action lawsuit covering 2011 through 2014 MaxxForce 11 and 13-liter engines for $135 million, with the settlement approved in January 2020. They eventually abandoned the MaxxForce line entirely, switching to Cummins-supplied engines and later developing their A26 engine in partnership with Volkswagen. The Workstar with the MaxxForce heart, one of the most reviled dump truck platforms in modern trucking history. Number 9. The Terex 3319 Titan. Now let's go back to 1973 and talk about a machine that was genuinely historic, but also genuinely problematic in ways nobody anticipated. General Motors, through its Terex division, assembled the 3319 Titan at their London, Ontario plant in Canada. At the time of its construction, it was the single largest truck ever built on the planet. Nothing else came close. It had a payload capacity of 350 short tons, that's 700,000 pounds of material in one load. The machine weighed 509,500 pounds empty. Fully loaded, it tipped the scales at over 1.2 million pounds. It was powered by a 16-cylinder locomotive engine, an Electromotive Division 16645E4, producing 3,300 horsepower. The tires alone stood over 11 feet tall. GM put the Titan into service with Kaiser Steel at their iron mine in Eagle Mountain, California, in January 1975. And here's where the hated part of the story begins. The Titan experienced frequent and serious downtime. Only one was ever built, ever, which meant that when something broke, there were no spare machines to cover. Parts availability was a nightmare, since everything about the truck was custom and one of a kind. Over 4 years at Eagle Mountain, it hauled approximately 3.5 million short tons of material, which sounds impressive until you realize how much of that time was spent broken down rather than moving ore. Mine operators found the machine extraordinarily difficult to maintain and operate efficiently. In late 1978, the Titan was shipped north to Kaiser Steel's mine in Sparwood, British Columbia. The mine changed hands several times, from Kaiser Steel to BC Resources in 1980, then to Workstar Mining in 1983. Workstar actually bought the Titan from General Motors for just $200,000, a fraction of what it cost to build, plus $1 million in spare parts. The price tag alone tells you how little the industry valued this machine by that point. Nobody wanted to buy an ultra-class haul truck that was so difficult to keep running that the manufacturer practically gave it away. GM never built another one. It remained a prototype, a single lonely experiment. After 13 years of service, the Titan was taken permanently out of commission and placed on static display in Sparwood, British Columbia, where it serves today as a tourist attraction. The world's largest truck, too big to be practical, too complex to be profitable. A cautionary monument to ambition without scalability. Number 8. The Ford C-Series dump truck. The Ford C-Series, also known as the Ford Tilt Cab, had a production run from 1957 all the way to 1990 in North America, which might make you think it was a success, and in some applications it worked reasonably well. But as a dump truck, particularly in heavy construction and municipal hauling roles, it built up a legendary reputation for driver misery and maintenance headaches that haunted it for decades. The cab-over design, where the entire cab tilted forward to access the engine, sounded clever in theory. In a dump truck environment where the machines work in brutal conditions with constant vibration, mud, rock dust, and temperature swings, that cab-over setup created chronic sealing problems. The cab tilt mechanism wore out, cab mounts cracked, drivers reported rattles and vibrations that made long shifts physically punishing. The ride quality compared to conventional trucks of the era was notoriously harsh. The C-Series was powered by various engines over the years, including early Ford gasoline engines that were badly underpowered for serious dump truck work. Operators who needed to haul heavy loads on steep grades found the performance margins extremely tight. When Ford eventually offered diesel options, the reliability improved somewhat, but the fundamental ergonomic and structural issues with the cab design persisted. Municipal governments that spec'd C-Series trucks for their public works departments found that body cab integration created leaks and seal failures that led to rust issues far earlier than expected for a working truck. Shop mechanics disliked the cab-over configuration because servicing the engine, while theoretically easier with the cab tilted, required dealing with a worn tilt mechanism that, after years of abuse on job sites, often refused to function smoothly. By the late 1980s, customers were abandoning the platform for Freightliner's conventional hood dump trucks and other alternatives that offered better driver comfort and more straightforward maintenance. Ford pulled the C-Series from North American production in 1990, a slow, grinding failure across 3+ decades rather than a single spectacular collapse, but a failure nonetheless. Number 7. The Moxy brand collapse. Moxy Engineering was a Norwegian company with a genuinely interesting product, articulated dump trucks that developed a solid technical reputation in the earth-moving industry. Their first commercial model, the Viking Dod 15, launched in 1972, was the world's first 6-wheel drive articulated dump truck. 6-wheel drive became the industry standard. Moxy had a real claim to innovation. But from the early 2000s onward, the company fell apart in a spectacular fashion that left customers, dealers, and parts suppliers stranded. Here's the collapse timeline. After Komatsu withdrew from its partnership with Moxy in 2000, sales dropped sharply because the Japanese manufacturer had been providing a massive share of their sales network. Without Komatsu's distribution, Moxy's market access shrank dramatically. The Norwegian state, which owned a majority share through Olivin, tried to prop the company up by injecting 50 million Norwegian kroner to stabilize it, but the damage was done. In 2002, 51% of Moxy's shares were sold to a private company. The ownership shuffled multiple times. The English Thomson Group eventually acquired Moxy's assets after further financial difficulties. Then in 2008, South Korean conglomerate Doosan Infracore purchased the company entirely. Doosan tried to revive the brand as Doosan Moxy. It didn't stick. In 2011, the Moxy name was dropped completely. 40 years of brand history vanished. Operators who had bought Moxy trucks found themselves with machines whose original manufacturer had dissolved into a succession of corporate owners, with parts supply chains that were inconsistent at best. If you owned a pre-Doosan Moxy machine by 2011, finding factory support was a serious problem. Resale values collapsed. The articulated dump truck market that Moxy helped create was now dominated by competitors like Volvo, Caterpillar, and Bell, companies with stable ownership and robust dealer networks. Moxy's trucks didn't fail mechanically. The company's business structure failed catastrophically, and operators paid the price. Number 6. The early Caterpillar 797. Wait, the Cat 797 is on a list of failures? Let's be precise here, because this is one of the most important stories in heavy equipment history. When Caterpillar unveiled the 797 on September 29, 1998, at their Decatur, Illinois assembly plant, it was genuinely groundbreaking. The machine was designed to carry 360 short tons. It was powered by a V24 engine, created by mating two 12-cylinder Cat 3512 engines together into a single quad-turbo unit, producing around 3,550 horsepower. The fuel economy was approximately 0.3 miles per gallon. Each tire costs tens of thousands of dollars and requires 2 semi-trailer loads just to transport 6 of them to the assembly site. The 797F, the current generation, runs approximately $5 million new. Here's the problem with the original first-generation 797. Caterpillar made an unusual decision to use a fully mechanical drivetrain, a 7-speed planetary gear transmission, rather than the diesel-electric drivetrains that competitors like Komatsu were using in ultra-class haul trucks. This was a massive engineering gamble. The mechanical transmission on a machine this size handling these loads introduced stress and reliability challenges that Caterpillar had not fully solved when they rushed the truck into customer service. The first 2 units went to Caterpillar's Arizona proving grounds for testing. By the second quarter of 1999, Units 3 and 4 were placed in service at the Bingham Canyon Mine in Utah as production development units. Essentially, paying customers were beta testing the machine. Mining operators reported significant reliability issues with the first-generation 797. The mechanical transmission proved troublesome at this scale. Downtime in mining is extraordinarily expensive. Every hour a haul truck is not moving, or represents lost production worth tens of thousands of dollars. Mine operators who had committed to fleets of these machines and built their hauling plans around them found themselves exposed when trucks went down unexpectedly. Caterpillar replaced the first-generation 797 with the 797B in spring of 2002, just over 2 years after full production began, significantly increasing payload capacity and engine power while addressing the mechanical issues. The fact that a $5 million truck needed a fundamental redesign so quickly after launch was a black mark the company worked hard to overcome. Number 5. The International Paystar 5000. With the DT466, the International Paystar 5000 was marketed as a severe-duty construction platform, exactly the kind of vehicle that ends up as a dump truck hauling rock, gravel, and soil from quarries to construction sites. It was a widespread machine in municipal and contractor fleets through the 1990s and into the 2000s. The problem that made it despised wasn't the truck body itself, it was what was underneath the hood in certain configurations. When paired with the DT466 engine and the early emissions-era EGR systems that Navistar began implementing to meet EPA regulations, the Paystar became a maintenance nightmare for fleets doing heavy vocational dump truck work. The DT466 in its later EGR-equipped versions developed notorious cooling system and EGR cooler reliability issues. In the hard-use environment of a dump truck, constant starts and stops, heavy loading, working in extreme temperatures, these issues were amplified dramatically. Fleet mechanics found themselves doing EGR cooler replacements with alarming frequency on trucks that were supposed to be heavy-duty workhorses. The irony was painful. The more vocational and severe the duty cycle, the faster the emissions components degraded. A dump truck spending its days hauling full loads in a quarry was practically an EGR cooler destroying machine. Municipalities that had fleets of Paystars working as dump trucks for road construction and public works found their maintenance budgets strained by a constant rotation of engine-related repairs. While not as catastrophic as the full MaxxForce disaster, the DT466 EGR era turned a formerly respected platform into a truck that experienced fleet managers actively warned each other to avoid when speccing new purchases. Number 4. The Euclid R-85B. Euclid was one of the pioneering names in off-highway dump truck history. General Motors acquired Euclid in 1953, and the brand built a serious legacy in mining and earth-moving. But by the late 1970s and into the 1980s, the Euclid R-85B rigid haul truck became a case study in a machine that was technologically behind the curve in almost every way that mattered. The R-85B was designed to compete in the mid-range payload class for surface mining, a segment where Caterpillar and Komatsu were making significant strides with more modern engineering. The Euclid machine used older mechanical drive technology and a powertrain configuration that produced significantly more vibration and heat management issues than its Japanese and American competitors. Operators who ran mixed fleets, some Caterpillar 777s alongside some Euclid R-85Bs, consistently reported that the Euclid machines required disproportionately more maintenance hours per operating hour than the competition. In an industry where uptime is everything, that ratio matters enormously. Parts support became increasingly difficult as the market share eroded. GM eventually sold the Terex Euclid business, and the Euclid brand went through a succession of ownership changes that further complicated parts availability and dealer support. By the late 1980s, mine operators were actively replacing their Euclid rigid haul trucks rather than continuing to maintain them. The R-85B wasn't one catastrophic failure. It was a slow death by obsolescence and inadequate support, which in the heavy equipment world is just as fatal. Number 3. The Freightliner SD Series with early DEF system issues. This one is recent enough that many operators remember it with fresh frustration. When the EPA's 2010 emission standards came into full effect, every major commercial truck manufacturer had to incorporate selective catalytic reduction with diesel exhaust fluid (DF) systems. Freightliner's 108SD and 114SD dump truck models, popular in construction and heavy vocational applications, went through this transition along with the rest of the industry. But the early implementation of these DF and SER systems created operational nightmares, specifically in dump truck environments. Here's why dump trucks suffer uniquely with DEF systems. They operate in extreme cold, they sit idle for extended periods during loading cycles, they work in dust-heavy environments, and they experience constant vibration. Early SCR systems on these vocational trucks had DEF injectors that clogged, DEF lines that froze in cold climates, and NOx sensors that gave false readings in dusty work environments. When the DEF system threw a fault code, many of these trucks would enter a derate cycle, reducing engine power, even when actively hauling a full load on a grade. Having a loaded dump truck lose power on a steep quarry haul road because of a DEF sensor issue is not just an operational inconvenience, it's a genuine safety hazard. Fleet operators in northern states and Canadian provinces dealing with winter operations found themselves constantly fighting frozen DEF tanks and lines. The heating elements designed to keep DEF fluid thawed in cold weather were not robust enough for the duty cycles these trucks were subjected to. Freightliner and the engine suppliers worked through multiple software updates and hardware revisions over several years to address these problems. But operators who bought early generation 2010 to 2013 SD dump trucks with these systems endured years of frustrating, expensive downtime before the technology matured. The trucks that were supposed to be the clean solution became some of the dirtiest headaches the industry had seen in years. Number 2. The Mack Granite with MP7 engine. Mack Trucks has one of the most storied names in American heavy trucking history. The bulldog on the hood is supposed to mean something: toughness, reliability, grunt. So when the Mack Granite, their flagship vocational dump truck platform, started generating widespread complaints about the MP7 engine in its emissions-compliant configuration, it genuinely shocked the industry. The Mack MP7 is an 11-liter diesel engine that Mack developed in partnership with its parent company Volvo. When equipped with the 2010 emissions hardware, the MP7 in vocational, severe-duty applications like fully loaded dump trucks developed a troublesome pattern of DPF, diesel particulate filter, regen failures, and EGR system reliability issues. The problem was rooted in the nature of dump truck operation: constant stop and go, heavy loads, low-speed haul roads, and frequent idling. These conditions are the worst possible environment for maintaining a healthy DPF regen cycle. When a TPF doesn't regenerate properly, soot builds up. When enough soot builds up, the system forces a parked regeneration, meaning the truck has to sit stationary with the engine running hot to burn off the accumulated material. For a dump truck operator who gets paid per load, a 30 to 45-minute forced parked regen in the middle of a workday is lost revenue. When these regens were happening multiple times per week on some trucks, operators started calculating the real cost of ownership and came up with numbers that made the Mack Granite a harder sell than its legendary reputation warranted. Multiple fleet owners reported that EGR coolers on MP7-equipped Granites were failing at intervals far shorter than expected in heavy vocational use. Coolant contamination from cracked EGR coolers led to engine damage in some cases. Mack and Volvo worked through revisions to the MP7's cooling system and after-treatment calibration over subsequent years. But the early generation 2010 to 2013 Granites built a reputation in vocational markets that damaged trust in a brand that had worked for decades to earn it. The Bulldog took a hit it didn't deserve, or maybe it did, because those engineering decisions were made in Gothenburg and Hagerstown, and operators in quarries and construction sites across America paid the price. Number 1. The International Transstar, Paystar. With MaxxForce 13, we began our list with the MaxxForce scandal, and we're ending with the worst chapter of it, because the sheer scale of what Navistar International did with these trucks in dump truck, construction, and severe duty applications deserves its own spotlight. At the very top of this list, the Paystar and Transstar platforms, equipped with the MaxxForce 13-liter advanced EGR engine, represent arguably the most damaging product failure in modern commercial trucking history. Not just because the engines were bad, though they were genuinely, demonstrably bad, but because internal documents and sworn testimony revealed that Navistar's own engineers knew the physics of their emissions strategy were fundamentally flawed, raised those concerns to management, and were reportedly pressured to stay quiet. Recall what came out during the Tennessee trial. Emails between senior Navistar engineering executives stating explicitly that the physics of the EGR strategy is not sound. Former senior vice president testimony that the company did not test STET before sending these engines to market. An internal admission that customers were discovering problems Navistar would have found themselves with proper testing, problems they chose not to look for. And the company's explicit threat to terminate any engineer who proposed switching to SCR technology. For dump truck operators, the consequences were severe. Construction companies running Paystar dump trucks on quarry work reported trucks breaking down multiple times per month. The EGR coolers failed. Turbochargers failed. The emission system caused sudden power derates while trucks were loaded and moving. Resale values for 2011 and 2012 MaxxForce-powered international trucks collapsed so dramatically that fleet owners who tried to trade them in or sell them took financial losses on top of all their repair costs. The class action lawsuit covering buyers and lessees of 2008 to 2013 model year Navistar vehicles with MaxxForce advanced EGR engines grew to include trucking companies in states across the country. Navistar ultimately paid $135 million to settle the class action for the MaxxForce 11 and 13 engines. That settlement was approved in January 2020. The company also faced the $30.8 million judgment in Tennessee, $20 million of which was punitive because the jury found that Navistar had committed fraud. The MaxxForce line was discontinued entirely. Navistar switched to Cummins engines for their trucks and developed the A26 engine with Volkswagen technology to replace it. But the damage to the operators, the small family-owned construction companies, the municipal dump truck fleets, the contractors who had trusted the international nameplate based on decades of prior reliability, that damage wasn't fully healed by a settlement check. Businesses lost contracts because their trucks were constantly in the shop. Drivers lost income. Mechanics lost nights and weekends fighting problems that the manufacturer knew about and concealed. In the world of dump trucks, where a machine that won't move means money that won't come in, that is about as bad as it gets. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.